and take a look at the show crypto ISACEM. Check out the ISACEM security associations, and you can see here an active association with the destination peer, which is going to be the home router, and my source, which is the office router. The connection ID 1, and the status is active. So next here, let's check out show IPSec security associations. And you can see I only had 23 of 25 packets that successfully made it through there. And there we go, perfect. 23 encapsulations, 23 decaps, so it was sending and receiving 100% here as far as the ones that were actually transmitted. And yeah, it looks good to me. So we have verified we have end-to-end capabilities for pinging here, and we've seen which traffic is being defined as interesting traffic and which traffic is not being defined, and it's just making its way across without affecting our counters. So there's 4 more packets. Let's take another look here, and we have 27. So the 4 that we just sent from our loopback on the laptop added to the previous total of 23. And just to show one more time here, I'll come to the router, the home router, and we'll do an extended ping of 100 packets to the 172.16.2.10. Throw 100 packets at it. And you notice here, you can source the address or the interface. So if I wanted to source the interface that's pointing out to the to my laptop, I could source the fast Ethernet 01 interface, and it's going to have the same effect as if I use the the IP address of 172.16.1.1. So those packets went through 100%. Now if I take a look at packets here, you see it hasn't changed one bit. So it didn't match that ACL, it didn't define it, it didn't encrypt it in any way, shape, or form. The packets weren't encapsulated. And this is a very basic setup for an IPSec VPN tunnel via the command line interface. So just some things you should take away from this. You want to make sure that all of your elements that are required match on both sides. You're not going to have a successful VPN if these don't match. Another thing, make sure that you're defining your interesting traffic correctly without configuring that and defining which traffic you want encapsulated and encrypted. You're not going to have any actual VPN traffic that's being sent across. So with VPNs, we've demonstrated fairly simple to set up. This is a small environment, but it can scale to even corporate setups where you could have a VPN server and clients dialing in. You can use certificates or pre-shared keys. We'll get a little bit more into a detailed look at using certificates, and I'm also in the next lab show how to configure the site-to-site VPN using the SDM, because that's one of the requirements, one of the topics that's going to be on the CCNA security exam. I kind of wanted to introduce you to the command line interface so you could get a grasp and see how it works, because once you go into the SDM, it's much more streamlined. There's not nearly as much of a granular hands-on approach as far as the command line interface goes, because you're going to see a lot more of the options, and if you don't need the options, that's great. The SDM functions really well for almost any application, and you can use the feature that I showed on my lab regarding setting up the SDM to use with GNS3. Under Preferences, if you want to grab a configuration before it heads out to the router, you can specify the SDM to do that. I'm not going to get too deep into that subject now, and I will cover that on a later topic, where we'll also be setting up a syslog server and defining any traffic being sent to that server as interesting traffic. So a little bit of out-of-band management. We'll take a look at a few new topics as far as security goes and locking down our network. Thanks for joining me on this lab, and I look forward to seeing you in future videos.